Okay, today we're going to look at some problems from section 4.4 in our text that involve factoring polynomials. So here, our first one, we have a leading coefficient of a 1, which makes this one a little bit simpler. So two numbers that multiply to 64, excuse me, and add up to 16, and that's 8 and 8, which makes this a perfect square trinomial, which has the general form of a squared plus 2ab plus b squared. And so that will factor here to y plus 8 squared. In this case, a would be y and b would be 8. Okay, over here we have a difference of squares, because this is q squared minus 10 squared. And so that factors to q minus 10 and q plus 10. Our middle term, our AB term, would equal 0 because we'd have a negative 10q and a positive 10q. All right, so now we have a few that have leading coefficients other than 1. So I'm going to use our splitting the middle. So we're looking for two numbers that add up to our middle coefficient, or coefficient of x, which is negative 17. And then the same two numbers have to multiply to the product of our leading coefficient and our constant term, which is 30. So multiplying to a positive, adding up to a negative, both numbers will be negative. So we have negative 2 and negative 15. So we split our middle term. So we have 5x squared. And instead of negative 17x, I'm going to write it as negative 2x minus 15x, since that's the same. And now we're going to factor. So we look at these two terms, and what can we factor out of a negative 15 and a 6? And that would be negative 3. And that would leave us with a positive 5x and then a minus 2, right? If we distribute, we get back to where we started. So now we're going to factor the first two terms, and we have to have the same grouping of 5x minus 2, and we're going to factor an x out of both terms. So notice in this product here, we have a 5x minus 2, and the same here. So we're going to factor the 5x minus 2 out, and notice we're left with x minus 3. Okay, same thing over here, except this time what I'm going to do is I'm going to do a little bit of guess and check, and the reason why is because my leading coefficient is a prime number. So I know to get 3x squared I have to have a 3x and an x. And I notice that my constant term is also prime. So the only factors are 7 and 1. And so the only thing I have to really worry about is the sign. So I want to get to a positive 20, right? So I know that for negative 7, I will have 1 and negative 7, or negative 1 and positive 7. And so I can quickly see that this has to be a plus 7, because that would give me a positive 20x, minus 1, that would give me a negative 1, which would add up to the positive 20x. So sometimes when your numbers are prime for your leading coefficient in your constant term, it can be just as fast to use guess and check. Okay, here's a few more problems. Again, we have a leading coefficient other than 1. But the first thing I notice is that each of these numbers are divisible by 4. So I'm going to factor out a 4 to start. So that leaves me with 3x squared minus 7x minus 6. And so I'm going to do my splitting the middle. So two numbers that add up to negative 7 and multiply to negative 18, right? 3 times negative 6. And that would be a negative 9 and a positive 2. So I still have my 4. So now I'm going to split the middle term, and I'm going to write it as minus 9x plus 2x. So I'm going to factor the second two terms, and I can factor a 2 out, which would leave me with an x minus 3. And I know that I need an x minus 3 here. If I factor a 3x out of both of those terms, I'm left with x minus 3. So again, notice I have the x minus 3 in both terms that I can factor out, and I'm left with 3x plus 2. Okay, so similar here, notice that I have a monomial that can be factored out of all three of those terms, and not just a constant or scalar, but also I can factor out an x, and that leaves me with x to the 4th minus 6x squared plus 5. So this factors very similarly. Let me get another piece of paper here to show you that this x to the fourth minus 6x squared plus 5 factors very similar to that. And so here we're looking for two numbers that multiply to positive 5 and add up to negative 6. And so that would be minus 5 and minus 1. So notice here I have very similar, except I have an x to the fourth and x squared. So this would be x squared minus 5, x squared minus 1. So hopefully you can see the similarities in the factoring there. But now notice that I have a difference of squares here. So we're not finished with our factoring. So we will factor that to x minus 1 and x plus 1. So we always want to look and see, can we continue to factor or not? Now technically we could here, but we would have a radical, an irrational number, x minus root 5, x plus root 5. And for our purposes here, just for factoring, we're not going to do that. Okay, over here I notice I have two terms of binomial and I'm subtracting. So what I think about immediately is, do I have a difference of squares or a difference of cubes? And so what I see is a difference of squares, because 16 and 81 are both perfect squares. And so I have the quantity 4x squared squared minus 9 squared. So again, difference of squares, so similar to here, this will factor to 4x squared plus 9 to 4x squared minus 9. Now again, just as before, we don't want to automatically say we're done. We want to look. So I have a sum of squares that does not factor, but again, I have another difference of squares. So let me show you how that plays itself out. So this is the quantity 2x squared minus 3 squared. So again, another difference of squares, so we keep bringing down our sum. And this will factor to 2x plus 3, 2x minus 3. And I would call all of these factors prime. So similar to a prime number, that the only factors are 1 in itself, a prime factor here means that these do not factor anymore. All right, moving on to number 8. Again, I have a subtraction. I'm thinking sum of or difference of squares or difference of cubes, but neither one do I have yet. But I do notice that in both of these terms, I can factor out a 4. I see I have at least an x to the first in both terms and an x to the, or a y to the first in both terms. So when I factor that out from here, right, I'm left with a 1 from the 4 and the y and an x cubed. And over here, I'm left with a minus 8y cubed. So now I see that I have a difference of cubes here. So I have the 4xy, right? That's the quantity x cubed minus the quantity 2y cubed. So following our factoring for differences of cubes, we'd have x minus 2y. And then on our trinomial, we have the x squared plus the product of the a and the b. So that would be 2xy. Plus the b squared, which would be 4y squared. And we're done. Okay, just a couple more. So here we have a 4-term polynomial. It's a 4th degree. And again, what I notice is that I have a 2 and an x that can be factored out of each one of these terms. So I'm going to factor out the 2x. I'm left with an x to the third minus a 3x squared minus a 16x plus 48. So notice here I have 4 terms. So for me, this is very similar to earlier, and I'm pulling back here, when we had a splitting of the middle, right? We went from 3 terms to 4 terms. And then when here we did grouping, which means that we factored this grouping and that grouping. So if we start with 4 terms, we can just look at grouping immediately. So again, I have the 2x. So I'm looking at the second or the third and the fourth term rather, and I see that I can factor out a negative 16, and I'm left with x minus 3. So when I factor the first 2 terms, I have to be left with an x minus 3 again, and I would factor out an x squared. So I have the first factor that I factored out 2x. There's the x minus 3, and I'm left with x squared minus 16. So again, what we should notice is that one more time, right, we're left with another difference of squares. So that factors to x plus 4, x minus 4, and now we have 4 prime factors, so we're done. Okay, last question from 4.4, wanting to know, is 2x plus 5 a factor of that polynomial? So that's our factor theorem, and our factor theorem would say that this was a factor if we substitute what we would call our k, which taking our factor and setting it equal to 0 would be negative 5 halves. So if we were to plug negative 5 halves into this function and get 0, then this would be a factor. So from here we can apply our remainder theorem, and we can do synthetic division. And if the remainder is 0, then we know the function value is 0, and then therefore that's a factor. Okay, so working with our coefficients, we have negative 16 from x to the 5th. Notice we have no x to the 4th or x to the 3rd term, so those have to have 0 placeholders. We have a negative 250 x to the 2nd, and a placeholder for x to the 1st, x to the 0 or constant term. Right, so there's our x to the 5th, 4th, 3rd, squared, 1st, and 0 constant term. Okay, so bring down the first term, negative 16, and now we have negative 5 halves times negative 16. Let's see, 16 divided by 2 is 8 times 5, we get positive 40. We add, we still have positive 40. Negative 5 halves times 40 will be negative 100. Add, we get negative 100. Negative 5 halves times negative 100 is positive 250. Add, we have 0. Now all we're doing is multiplying by 0. And there's our remainder. So yes, since the remainder is 0, that is a factor. Okay, hope that helps, and we'll see you soon.